let us consider a more challenging problem. Suppose we're given a natural number little n and we want to check is n a power of 2 or not. So we will use the symbol capital N as usual to represent the set of natural numbers which are all non-negative integers, meaning including 0. So when we have to write code for a challenging function like this, it's good to try and first think about all the facts that we know about the function. What are its properties? Then it is useful to think about which features in the language we will need to actually write the code. So we will follow this two-step process for this function. So first, let's think about all the facts that we know about checking if a number is a power of 2 or not. So I'm going to give you 3 claims, and I'm going to put these claims inside double quotes because I'm not yet telling you if these statements are true or not. I want you to think about these things. So our first claim is that all powers of 2 are even. Our second claim is that 0 is not a power of 2. And our third claim is a little bit complicated. It's talking about all natural numbers n that are greater than or equal to 2. And it's saying that any such n is a power of 2 if and only if n is even and n by 2 is a power of 2. So there are many things to think about here, but I would like you to pause the video and think about each of these 3 claims, and then we will discuss. Please pause the video here. Okay, I hope you had a chance to think about each of these 3 claims. So claim 1 seems correct, and it's almost correct, but it does fail for one case because 2 to the power 0 is 1, and that is of course an odd number. And this is a good example of something that we face all the time in programming, which is special cases. They're sometimes called corner cases. So what we have to do as programmers is write special code to handle these cases. The second claim is 0 a power of 2 or not. Well, it depends on who you ask. So some people might say, well, if you look at powers of 2 to the power I, and you let I go towards minus infinity, then that limit is 0. So yes, we want to consider 0 as a power of 2. Other people might say, no, we don't want to consider these limits. We just want to look at powers of 2, just a fixed number n and 2 to the power n and so on. So depending on what we are trying to achieve with the program, we may have to make a certain decision. And again, this is something we typically do when we're writing code, and we may have to come back to this decision later on and change the code because we've decided, no, actually we want things the other way. So at least for this function, let us say that 0 is not a power of 2. Now, the third claim turns out to be true. And it's in fact a definition of what it means for a natural number n to be a power of 2. It is what is called an inductive definition in mathematics. And it seems circular, right? Because we're saying n is a power of 2 if and only if n is even, fine, and n by 2 is a power of 2. So we're defining what it means to be a power of 2 in terms of another number n by 2 being a power of 2. But although this seems strange, this is perfectly standard in mathematics, an inductive definition. And if we take what we know about these 3 claims and we write them in mathematics, we get this standard definition of what it means for a natural number n to be a power of 2. We say that n is a power of 2, so is 2 power n. This is defined as false, meaning it's not a power of 2 if n is 0. And it's defined as true, meaning n is a power of 2 if n is 1. And otherwise, it is what is there in claim 3. N is a power of 2 if n is even and n by 2 is a power of 2. So to make an inductive definition, it's absolutely necessary to have at least one base case. And in this function, we actually have 2 base cases. N equal to 0 and n equal to 1 are our base cases. Without these base cases, I mean, this process would never end. We would never actually define what it means for a natural number to be a power of 2. We will always be appealing to other numbers being powers of 2 or not. So we have to ground this whole thing in at least one base case. And for this function, we happen to have 2 base cases. Now, this mathematical idea of induction corresponds exactly to an idea in computing, which is called recursion. Right? And it's essentially the same thing. It's like 2 different names for the same thing. So what we are going to do is we're going to write a recursive function to calculate whether a given natural number is a power of 2. So this was our first part. We were thinking about what we know about natural numbers being powers of 2 or not. Let us now think about which features in the language we will need to actually write this function. So you notice that this is2power function returns essentially a true or false value, right? The base cases are either true or false, and then the inductive case, the last case, is essentially the AND of 2 conditions. So again, it's going to, if you take an AND of true and false, or false and false, or true and true, you're going to get either a true or a false value. So this is a function that takes a natural number as input, and it returns either true or false. So we will have to write some type that captures true or false in C. Unfortunately, in C, we don't have a way of indicating true or false. So what we have to do instead is we have to fake it using an int. So over here, I have written what is called just the prototype of the function. We have simply said that this is what the function is going to look like in terms of its return value, which is int, and in terms of its arguments, right? So in this case, it's going to take an unsigned int natural number as an argument. And I've put a semicolon at the end to indicate that I have not yet implemented this function. I haven't yet showed you its code. This is just, you can think of it as a promise to have such a function written out in the future. So sometimes when we are trying to write a function, it's very important to get the prototype correct. What are the arguments that it's going to take? What are their types? And what is its return value? And this helps us think about how we are going to design the function. In this case, since we had to think about how is the function going to return true or false, we are thinking that, all right, it's going to return an int, and maybe we can use 0 to represent false, and maybe 1 can represent true. We could choose some other representation, but this seems good enough, and it's in fact quite standard. In C, usually statements that are true, you represent those as the value 1, and statements that are false are usually represented as the value 0. So we will follow this convention, and now we will start thinking a little bit more about other language features that we need. So let us copy paste this definition, this mathematical definition of is2power to our next slide. And let's think about how we're going to write code for this. Notice that there are 3 cases. And we already know that if there are 2 cases, then we know how to write code for that, right? We write if else. So if some condition, we do the first case, and otherwise we do the second case. So here we have 3 cases. And one way we can make that happen inside a C program is, if some condition is true, maybe if n is 0, we can handle the first case. But otherwise, we have 2 cases, and inside the else, we can put in another if condition. This is something called nesting. So I have nested another if condition inside the else. And this lets me split between the second and the third case. So I could write an if condition that helps me distinguish between n equal to 1 and otherwise, meaning n is neither 0 nor 1, meaning it's greater than or equal to 2. So this is a simple way in which we could handle multiple cases. Now you see that because of my indentation, my second and third case are pushed down a level, and there's nothing wrong with that. But if we look at the mathematical definition, there are three cases at essentially the same level of importance, and I would like to write my code also in a similar way. And it turns out that C offers me a mechanism in the language. If I look at my first else condition, I have else if something else, right? So C allows me to sort of glue that else and if together, and I can write code like this. So I'll have if some condition, I'll do the first case, else if some other condition, the second case, else the third case. Of course, I can have any number of else ifs in between, and then I could handle any number of cases. So that's the code structure that I'm going to use. We also need to talk about how do we check if n is 0 or not. I mean, it seems like a very simple thing, but it turns out we have to be very careful in checking if a value is equal to another value, because in C we have to use a double equal to, not a single equal to. It turns out that in C, if you were to write this statement n double equal to 0, as we have done, then that is checking if n is equal to 0 or not. But if you were to write n single equal to 0, that means something totally different. And unfortunately, in C, both those statements would work in this piece of code. And this is actually one of the dangerous features of C, which many students find challenging and they make mistakes on. So it's very important for you to remember that if you are comparing two values and checking if they're equal or not, you have to use double equal to, not single equal to. So we would write code like this: if n double equals 0, and that would handle the case when n is 0. We'll decide what to do there. And similarly, if n is 1, we'll write n double equals 1, and then we'll handle the second case. And then lastly, in the else, we'll handle the third case. So with all those in mind, let us now try and write the code, and then we'll come back and discuss this further.